Normally when you drop a ball, it can't bounce higher than the height it started from due to the conservation of energy, but not this one. Okay, I'll drop it table height and it'll go higher than the table. Whoa. So watch this. Whoa. Look how high it went after I dropped it. How is this even possible? With a normal ball, in a best case scenario, the highest that a ball can bounce to is exactly the point that it was dropped from. In that case, it would be perfectly elastic with no energy loss. But in real life with real materials, there's always some energy lost as heat and sound and sometimes plastic deformation. The height that a ball gets to after it's dropped depends on its coefficient of restitution. The higher this coefficient, the closer it gets to the original height. Using a metal ball bouncing on a balloon stretched over a cup, you can get a coefficient of restitution that's very close to 1, but it never goes over 1. If it went over 1, that means that you're actually gaining energy when you drop the ball instead of losing it. So what's going on with this ball? Well, you might have already noticed that this ball looks a little odd. That's because it's actually a balloon with something else elastic inside of it. So what's inside here? With this hollowed out half sphere here, we can inverse it. This provides a bunch of energy stored elastically in the bonds of the rubber. And then when I drop it, the energy is released and the shell reverses its shape and the middle hits the ground at high speed. This sends it flying in the air way higher than where you dropped it from. In fact, the height that you drop it from almost doesn't matter in this case, because almost all the lifting energy is coming from the elastic deformation of the shape before you drop it. So if I just put this in a balloon and then deform it, see, I can put it inside of the balloon like this. And there you go, a ball that bounces higher than where it was dropped from. So anytime you see something putting out more energy than you put into it, that means that there was already some energy hidden inside of it in the first place. For example, when we magically get energy from burning fuel to make a car move, we know that the real energy was already loaded in the carbon and oxygen atoms. But how was it stored? Well, we usually hear that it's stored in the chemical bonds of the atoms, but a better way to say this is that it's stored in the separation of the reacting molecules. Once the atoms combine to form new bonds, that's when the energy is released. So the fact that carbon and oxygen are not CO2 means that some energy had to go into separating them at some point in the past. And once they're separated, that energy is stored in the atoms until they combine again. Sometimes this stored energy is hidden in really interesting ways, where it can seem like we're just getting free extra energy. But even in nuclear energy, that seems to just be free endless energy. We know that the energy is stored as mass. So in almost every case, we always find the original energy source when there seems to be extra energy somehow. This is how the laws of thermodynamics were established. But here's a question for you. Notice how I said that in almost every case, we can find the original source of energy. But what about the universe? We know we can never get any extra energy in the universe, so where did all the energy come from in the first place? What's hidden inside the balloon of the universe? And thanks for watching another episode of the Action Lab. If you haven't subscribed to my channel yet, please consider subscribing if you enjoyed this video. And thanks for watching, and we'll see you next time.